We'll start. Okay. So good evening, guys. So in last class we have seen about the motion in a straight line, right? So the topics which we have completed are, so the topic is going on is motion in a straight line. This is the topic is going on, right? So under this we have completed the reference frame, next is the definition, basic definitions we have completed now, the distance, displacement, right? एक minute man, Lincoln. Now it's clear, right? Once you check it. Now you check, man, it's clear right now. Okay, fine. Okay, displacement and then velocity, right? Then speed we completed, acceleration, right? So once again we will recall everything, okay? So first thing we have seen what is motion, right? So motion, like if an object is in motion, we will say by the reference frame of the other object. No? Like if I say object A is in motion, with respect to B I will say like B is there but A changes its position from one point to another point, then I will say the object is in motion, right? No? So by in that I am using the reference frame. And when we go for the next thing, the distance and displacement, okay, so displacement is nothing but final position minus initial position, like final position is there and initial position is there. So in displacement the path is main thing, the path travelled is main thing, no, but in distance the actual path we are travelling, in displacement the shortest path we are travelling, right? No, and we have seen the units also for both the distance and displacement, units are meter, okay. And then we have gone for the velocity and speed. So what is velocity? It's nothing but change in position with respect to time, okay. Displacement is nothing but change in position, but with respect to time if I take, it is velocity, okay. Yeah, and then speed is nothing but distance by time. So for both velocity and speed, it is meter per second is the SI unit, right now. So if they are asking for the CGS unit, what is the difference between SI unit and CGS unit? SI unit and CGS. So in SI unit we will take in terms of MKS, no? What is M? Meter, K is kilogram and S is seconds, right now S is seconds. And in CGS, C is centimeter, G is gram and S is seconds. That's what, no? This is centimeter, gram, seconds, and this is meter, kilogram, seconds, right? Okay, so this is the thing we have seen. And acceleration, one more thing. What is acceleration? Rate of change of velocity with respect to time, right now, and the unit is meter per second square, okay. Apart from this, we have seen two more terms, that is instantaneous velocity and instantaneous acceleration. So the meaning of instantaneous is nothing but at that particular moment, right? No, instantaneous. Yeah. So at that particular moment. Okay, at that particular moment, right? Okay. Now, if I talk about the instantaneous, no, like I am going with some speed, x speed, from point A to point B, but in between any, like that point, no, I am asking what is the speed. You are saying 60 km/h. So that is the meaning of instantaneous. No, at that particular time I am asking and you are saying the speed. Okay, that is the meaning of instantaneous. Okay, and the two things are there, one is scalar and one is vector, right? Now, so in this, distance is scalar, distance is scalar and displacement is vector. Right now it is a scalar quantity, it is a vector quantity. So what is the meaning of scalar and vector? Scalar is nothing but have only magnitude, no direction further, but for vector both magnitude and direction. Okay, and the thing is distance, or I will take displacement is less than or equals to distance. This is the main thing. No, distance can be 0 or positive, but it can't be negative, but displacement can be negative, 0 or positive. Right now when I walk front, some x meter has been covered, if I come again back, some x meter has been covered. If they are asking for distance 2x, right now x plus x 2x, but what about the displacement? Final position minus initial position. No, we are talking about the position, the path has been travelled, so x minus x will be 0. So when I travel from point A to again point A, displacement will be 0, but distance will not be equals to 0. Okay. Next we have seen about the kinematic equation, no, that one dimensional motion. Na? So in kinematic equation, the main thing what we have learned, when acceleration is constant, we can use the kinematic equation, right? So what are the kinematic equation we have seen? A minute. Yeah. So what are the kinematic equation? V is equals to u plus at, v square minus u square equals to 2as, and s is equals to ut plus of at square. Right now, and one more equation for the nth time. No, so what is that? Sn is equals to u plus a by 2 into 2n minus 1. Right now, so these are the 4 equations we have learned, and we have solved the problem for these 4 equations also in last class. Now we will go ahead, that is a vertical motion. Okay, freely falling body and then an object has been thrown upward. Okay, two things we are going to see and we will solve problem further. Okay. So vertical motion, and one thing we are going to see for one dimensional only. Okay. Okay, one dimensional. So what is the meaning of vertical? Upward or downward, like in x axis or y axis we will say, no, this x axis and this y axis. So y axis is vertical and x axis is horizontal, we will say. Okay, keep in mind. So when I take an graph, this is my x axis and this is my y axis, where x is said to be in horizontal and y is said to be in vertical. Okay, rows and columns we will say, no. Okay, yeah. So now we will talk about the motion. Okay, vertical motion. The first one we are going to see is freely falling body. Okay. So in freely falling body, if I leave the object like this, which thing is taking the object to the surface? Gravity. Gravity helps me to take the object to the surface, right? No? So one more thing, what is the direction of the gravity? Towards center of the earth. Yes, no? It's downward. So first we will say that gravity, that is towards down. Okay. And free falling body, no? So if I take an object like this, so there is an object, okay, I am leaving the object just as it is. Am I applying any force in this object or any velocity I am applying here? No, nothing. So what is the initial velocity? 0, right? No? So initial velocity will be u will be equals to, u will be equals to 0. Suppose, let me consider this is the surface. Okay, this is the earth surface. So I am leaving the object and it's traveling the h distance, the height. Okay, at a height h, I am taking the object, I am just leaving the object. So it's traveling h distance and reaching the earth. Yes, no? If I leave the object for 1 meter or 1 centimeter, I will take 1 centimeter. If I leave, some impact will take place. But if I take that same object and if I leave from some 100 centimeter height, the impact will be more, which means the velocity is increasing there, no? Yes, no? It's because of height and gravity. Yes, no? And velocity is increasing. Let me consider the final velocity is v. I need to find what is v. Okay? So what are the terms here? We have one is u, one is h, one is v and one is g. G is nothing but the acceleration taken place for the ball. Okay? That is gravity. So what is the value of gravity? G is equals to 9.8 meter per second square will take. Right now this is the value, but in problems we will take approximately it is 10 meter per second square for calculation purpose. Right now. So in some question if they mention use 9.8, use 9.8 only. Okay. So for calculation purpose, no, if they have not mentioned, you can take 10 meter per second square as it is. Right. Now I will write the equations here. What are the equations now? V is equals to u plus at, v square minus u square equals to 2as, and s is equals to ut plus of at square. Now let me take what are the given terms there. Okay, so u is equals to 0, I need to find v, and s is equals to h, the displacement has been taken place, right, that is h. Okay, and a is equals to plus g or minus g? Minus. I am opposing gravity, I am going towards the gravity. I am going towards the gravity. Now if I oppose the gravity, it is minus. Right now it is only plus g. Okay. Now let me take these values and substitute in these three equations. Okay, and I will get the unknown terms. How much time it has been taken to reach from the top of the tower to the surface. Okay, and what is the velocity that has been taken to the bottom of the surface. Okay, first equation let me take. Okay, equation number 1, that is v is equals to u plus at, where v I don't know, I will keep as it is equals to u is 0, right? U is 0 and acceleration is g and t. V is equals to gt. I will keep as it is. Now what about the second equation? First equation we got, this is the value. For the second equation, v square minus u square is equals to 2a s. Right now, what is v square? I don't know. What about v? I need to find v. Right now, v square minus 0, no, u is 0. I'll keep as it is u. Dheeraj, why is initial velocity 0? So initial velocity 0 because I am leaving the object as it is. No, I am not applying any velocity there, or I am not pushing the object, I am just leaving. If I take the object, see, if I take the object like this, no, if I leave, I am just taking the hand, that's it, right? Now because of gravity it is going down. If I take the surface, I am catching the object. If I take out my hand, is it going down? No. This is the maximum thing it can, right? No. But if I take to some height, if I leave, it is going down, right? Just I am leaving that. So initial velocity will be 0 there. Hope you got it, Dheeraj. Okay, fine. So what is the next thing? It is 0 square is equals to 2gh, no? So I can neglect this out. So v will be equals to under root of 2gh. So this is the answer I got from the second equation. So what is the velocity in terms of h? V is equals to root over 2gh. What is the velocity in terms of t? V is equals to gt. Okay, done. So if I want t to find the time, no, what is t? T is equals to v by g. Am I correct? No. From this equation I can write what is t, right? T is equals to v by g, the final velocity by gravity. What about the third equation? S is equals to ut plus of at square, no. So in this 0, no, u is 0, I can neglect this. So h is equals to 1 by 2 g t square, right? No. So I can write t in terms of h now. How can I write? I can take this 2 to the other side of the equation, right? No, and g to the other side of the equation. So I can say t square should be equals to 2h by g, where t will be equals to under root of 2h by g. So what, how many unknown we got here? 2 unknowns, and one more thing, I mean 3 unknowns we got. So in that 2 are similar, but in terms of other variables, right? No. So first thing, t is equals to v by g, that is velocity by gravity, that is final velocity. Okay, and here v is equals to under root of 2gh, and t is equals to under root of 2h by g. Okay, hope you got this one. Understood now? This is for the free falling body. Okay, you can copy this one. We'll go for the next thing, that is an object has been thrown upward with some initial velocity. Initial velocity is not equals to 0 in that case. Okay, you can copy this one. We'll go for the next thing. Done? Clear, right? We'll go for the next thing. Okay. So what's the next thing? This is for the free falling body, na? Next thing is second case, an object has thrown upward. right now. If I want to throw the object upward, I am keeping the object. If I want to throw this object, what I should do? I should apply some minimum force, right? No? Yes or no? If it reaches some height, again it's coming down. Why it's coming down? Because it has reached the velocity, that is final velocity has become 0, right? No? Final velocity becomes 0, that's why it is coming down, right? Now let me consider now, I have an object which is having initial velocity as not equals to 0. I don't know, I need to find what is the initial velocity now. Okay, now this object is going for height h, that is the maximum height it has been went. Okay, maximum height it has been went now. Now what I will do, I will consider the final velocity as 0, right? Now after going up, now if I throw something, it will go up to the certain height and it's come down, no? Yes, no? In this case final velocity will be 0. Okay, so what is the direction of acceleration now? Direction of acceleration, it is towards up, no? It is towards up, no? Yes, no? Yeah. So gravity is towards down and A will be towards up. So what about A? A will be equals to minus G, right? No? Minus G. If acceleration and gravity both are in the same direction, I can take A as plus G. But whereas in this case, acceleration is towards up, but gravity is towards down. So I should consider it as a negative, right now. Now I know V, final velocity, initial velocity is there, A is there, H is there. Now let me take that equation. So what is the first equation? V is equals to U plus AT. Next is V square minus U square equals to 2AS. Next, S is equals to ut plus of AT square. Same thing I am going to find for these cases also. Okay. So what's the first one? Let me consider the first equation. V is equals to U plus AT, where V is 0, right? V is 0 is equals to, what is U? I don't know about U. I will keep as it is. U plus minus G, no? Minus G into T. So U will come this side, means minus U is equals to minus GT, minus minus gets cancelled, T will be equals to U by G. Am I getting the same thing here? In the previous case I got T is equals to V by G, velocity by gravity, right? Here also I am getting the same thing, no? Right na? Yes or no? We are getting U. One thing, when we will say it's equal, when I consider the previous case height and this case height are equal, right? No, previous case height is some h, this case height is h. So in this case velocity and other case velocity both are equal in that surface. Yes, no? But here top 0. In that case also 0, I am just leaving. Here I am throwing. Okay. So don't confuse between this, like just write the equation. Okay. And yeah, and draw the diagram. Whatever they are saying, you can draw the diagram and apply that equation in that. Okay, that condition you can apply in this equation and get the equation and solve the problem. Okay, fine, no? So what is the next equation? V square minus U square equals to 2AS, no? So what I can do here? Completed, right? No? We'll go for the next thing. Yeah. Second one is V square minus U square equals to 2AS, right? So what is V square? V I don't know. I will keep as 0. Yeah. Okay. So V I will keep as, V I don't know, this is 0, right? No? So maximum height case, no, we are considering. So V 0 square minus U square is equals to 2 into minus G into H, na? A is minus G, S is H, the displacement taken place from final point to the initial point, na? Initial point to final point, right? No? So I can neglect this out, minus U square will be equals to minus 2G H, where minus minus gets cancelled. u will be equals to under root of 2gh. Hope you got it now what I trying to say. Here we got v is equals to root over 2gh, the final velocity at that surface point. When I consider the equal height for the both cases, okay. So this is the final velocity, okay. This is the final, initial velocity, sorry. This initial velocity for throwing the object towards up, okay. This is initial velocity for throwing the object towards up, right? Now done. Now what is the third equation? I guess it's clear, no? Rocking star, Aki Abi, it's clear, no? Like the board is visible right now. Yeah, fine, thank you. So what is the third equation? S is equals to ut plus of at square, right? In this I can take this u, I can substitute the value of u here, right? I can substitute the value of u. So what is h? H is equals to u t plus 1 by 2 into minus g into t square, right? So this is the thing. I can solve by taking t to the one side and remaining term in the other side, okay. Either I can use the previous equation also, t is equals to u by g. One thing you should understand here is, when I take an object, no, I am taking an object, I am throwing upward with initial velocity u and it reaching the maximum height h and the final velocity becomes 0. How much time it has been taken? T is equals to u by g, no? That's what we got in the first case, first equation. So this is for going up. Again for coming down, what is the time? Same time, okay. So I'll write here t is equals to u by g. This time is for, this time is for going up, okay. And total time, no, I'll write capital T. T is equals to 2u by g, which is nothing but going up 1 and coming down 2, right? No, wait, yeah, I get.
But while coming back down, the velocity, final velocity should be equal to u.
See, wait, for example, you are traveling for x distance, okay, from point A to point B. Again coming from point B to point A. For x distance you have taken t1 time, you are going with same speed and coming back also same speed. How much time you will take? Same t1, no? That's what? Yes. The thing is, here what is the thing? We should consider time in positive case, right? No? When I throw the object, gravitation, no? Gravitation will be negative, opposing, but towards down again gravitation positive.
So it will be faster?
No.
When it drops down?
That's what, you, whenever you are throwing with some velocity like u is equals to 10 meter per second, it will go to the height how much ever velocity you are applying. But if you throw with some other like 100 meter per second, it will go some other height, no? Yes, no? Yeah, same thing. Like energy has been, you are giving kinetic energy. After height h, it has been stored as potential energy, again kinetic energy, no? Here nothing has been taken, like energy has been conserved, no, here. Yes, no?
But at the top of the point,
V is equals to 0.
So u is also equal to 0 at the second step.
Yes, in second step u will be 0. Yes, and when it's coming down, like same velocity will be there, no? V is equals to u root over 2gh. Understood? Yeah. So I'll write here, this is the total time. This is the total time, which is nothing but for going up and coming down. Understood? No, it's clear about the vertical motion. So in vertical motion we have seen two topics, one is free falling body and one is throwing object upward. Done. We'll see some problems regarding these questions now. Okay. Have you noted these points? Yeah. So the first question, I hope it's clear, I mean visible, no, the questions are. Sorry. Is it visible now, the questions? Okay. If a body is thrown up with a velocity 15 meter per second, then the maximum height attained by the body is, take g is equals to 10 meter per second square. So let me write first what is the given terms there. So whenever you are appearing for the question, no, read the question, the first half, write whatever they have said, and second half, and if any equations are there, write that equation and solve it. We will see first whatever the given terms are. Velocity, no, throwing up in the sense object is there, I am throwing up, so u will be equals to 15. Then maximum height, no, maximum height means what? V will be 0, V will be 0, and h max I need to find the maximum height. Okay, what is the gravity? Towards down g, but acceleration will be minus g. Okay, can you give answer for this question? Guys, whoever watching in online, no, like they also can give.
So if you have to find time, then the third equation.
Yeah, you can find and you can say. Either you can use.
I'm getting 0.
We'll solve. You'll solve it and we'll see the answer. Guys, you also can give answer. Whoever watching in online, no, can give answer in the comment boxes. We'll check the answers once we'll solve. Done? Okay. So listen. So what are the equations we know? 3 equations. V is equals to u plus at, V is equals to u plus at, V square minus u square equals to 2as. So let me write every equation, and one more thing, s is equals to ut plus half at square. So V is equals to u plus at, V square minus u square equals to 2as, s is equals to ut plus half at square. Okay. So whatever I told, I have written everything. Now can I use the second equation? In second equation s is there, a is there, I have a, I have s, but I can't use first equation, t is not there, no, t is not there, I can't use the first equation, right?
So you can use the second equation.
Yeah, second equation we can use, no. That's what, like third equation you told, na, like I can use third equation by using the time.
But we are getting 0.
Yeah, wait, let me explain. First I will take the second equation. So in this everything are available, no? Everything are available. What is V? 0. So let me take the second equation and apply. V square minus u square is equals to 2as, where V is equals to 0 square minus, what is u? How much they have given? 15. Okay, 15 square is equals to 2 into minus 10, no? G is 10, so A is minus of G, so minus 10, so into H, I need to find the value of H, right now. So what is this? I can neglect it out. So minus how much? 15 square, 225, right now. 225 is equals to minus 20H. Done. So minus and minus get cancelled out. 225 divided by 20 is equals to H, where this is 4 times I can say, and this is 40, I mean this 4 times and remaining 2 is 45 times. Then 45 times. Now what I can say, like 45 divided by 4, no, 11.25, that's it. Option 1. So h is equals to 11.25 meter. This is the answer, guys. Because totally blurred video streaming. Okay, I'll check it because I'll check the camera. Okay. Thanks for the information. Done, no? Can we go for the next question? Yes. I'll zoom it little bit. I guess it's clear, right? It's visible, no? Now, okay, a body falls from rest. So what's the thing they are using here? Free falling body, na? Body falls from rest in gravitational field of the earth. The distance travelled in the 5th second of its motion. So what I told, when they are talking about the 5th second or nth second, I should use the 4th equation. Yes, no? So what is the 4th equation? Sn is equals to u plus a by 2 into 2n minus 1. Right, no? What is n they have given? 5. 5th second, no? N is nothing but t. St is equals to u plus a by 2 into 2t minus 1. Okay. Let me consider n is equals to 5. That's what they have mentioned here. Okay. What is g? G is a. A is equals to g, no? Gravitational field, right? Gravity. Now can I write s 5th second, okay, is equals to u is 0, right? U is 0, rest, okay, 0 plus 10 by 2 into 2 into 5 minus 1. Done, no? Any doubt in this case? Okay. Now what I can do here? This is 1 times and this is 5 times. 5 times. So 5 into, this is 10, no? 10 minus 1 is 9. So 9 5s are 45. So distance travelled in the 5th second of its motion is 45 meter. That's the answer for this question. Yes, 45. Yes, Sabi, it's 45. Yeah. Can we go for the next question? Can we see? Yeah. So what's the next question? I'll zoom it little bit so that you can see. Yes. A very large number of balls are thrown vertically upward. Okay, vertically upward. So balls, like many balls are there, they are saying. Okay, one by one they are throwing upward. Okay, vertically upward in quick sessions. Quick sessions in a sense like n number of balls are there. I am just throwing the ball like this. Okay. Wait. Sorry for the disturbance. It's getting, yeah. I hope it's clear now. Okay, Abhishek. Okay. Yeah, it's clear, I guess now. Once you see now. It's clear now? Check it. Yeah, thank you, Abhishek. Yeah, fine. So there is n number of balls I am throwing upward in quick sessions. The next ball is thrown when the previous one is at the maximum height. So what's the thing they are saying? I am throwing one ball. It went to maximum height, and in that time I am throwing another ball. Again that second ball going to maximum height. The third ball I am throwing. Okay, and the third ball is going to maximum height, and fourth ball I am throwing. Okay, in quick sessions I am throwing the balls now. So the previous one is at the maximum height. If the maximum height is 5 meter, the number of balls thrown per minute is. Understood? Yeah. Let me write the given terms first here. So there is n number of balls. So let me consider the first ball here. So I am throwing with thrown vertically. So I should have some velocity, right? Is they have mentioned the velocity? No. I need to find it. So the maximum height, so velocity will be equals to 0, final velocity will be equals to 0, and then h max, how much they have given? 5 meter, no? 5 meter. So what is the value of A? A will be equals to minus g because gravity is towards down. I am throwing the object towards up, right? I am throwing the object towards up. Now what are the things they are asking? Per minute they are asked. I need to find the time. In this case, I don't know what is the value of u also. I need to find both of them. First I need to find u, then only I can find what is the t. Yes, no? See, per minute they asked. Per minute they asked means like for 1 second how many ball I can throw. If I find for 1 second, no, for minute I can say like 60 into 60 I can say, no? Yes. So whatever we are taking, no, everything are SI unit, but this is minute, no, I should convert it, right, no? Yeah. So first we will find here. So what is the thing? V is equals to u plus at, v square minus u square equals to 2as, s is equals to ut plus of at square. So from this, by using equations, which one I can use to find u? First one, no, I don't know t in the first equation. Second one I can use, na, easily I can use the second one. V I know, that is 0, obviously. Maximum height, no, it is 0. Yeah, yeah, Abhishek, yeah, we'll see, we'll check the answers. Okay, yeah, it's correct. You gave the correct answer, man. Yeah, n equals to, yeah, correct. So second equation I will take. So v square minus u square equals to 2as, where it is 0 square minus u square equals to 2 into minus 10 into what is height? H, that is 5. So minus u square equals to minus 2 into 10 into 5, minus minus get cancelled, u will be under root of, how much this is? 2 into 5 is 10, 10 into 10 is 100. So 100, no, so under root of 100 is 10. So what is the velocity? Initial velocity 10 meter per second. So by using this I can take the first equation now. Either I can use the second equation also, no issues, but second equation little one more step will be there, but I can use the first equation easily. Yes, no? So for the first equation, v will be equals to u plus at, where 0 it is, v will be equals to 0, u will be equals to minus 5, so minus 10, no, so sorry, minus 10 it is, plus minus 10 again into t, sorry, it is 10, right, only 10, when it comes to this side it will become minus 10, so minus 10 is equals to minus 10 into t, minus minus get cancelled, 10 get cancelled, t will be equals to 1 second. So we have considered for one ball. So one ball takes 1 second to reach the maximum height. So for 1 minute, how many balls? 60 balls, no, obviously. So 1 second, one ball. 60 seconds means 60 ball. So how many balls now? Number of balls equals to 60. This is the answer. Done? Yeah, Abhishek. Answer is 60. You are right. We'll go for the next question. We'll see. Yeah. So the next question, it's a theory question. You can read the question and you can give the answer. A body is thrown upward and reaches maximum height. Okay. At that position, its velocity is 0 and acceleration is also 0. First thing, understand that gravity becomes 0 in Earth when I am throwing the object. I am throwing the object like this. Is gravity becomes 0? Velocity becomes 0. Because of gravity is opposing, due to the force I have applied, no, it is not minimum, not enough to go to the height. Yes, no? So option 1 is not correct. Option 1 is not correct. First, okay, this is correct, but second part is not correct, no. What about the second one? Its velocity is 0, but its acceleration is maximum. Third one I'll take. Acceleration maximum. I'll read the third one also. Its acceleration is minimum. Acceleration maximum they told, acceleration minimum they told. Now fourth one we'll see. Its velocity is 0 and acceleration is the acceleration due to gravity. Now tell the correct answer. Maximum acceleration or the acceleration due to gravity will be the answer. Acceleration due to gravity will be the answer, because we are considering the gravity as an acceleration. In both the cases I am leaving the object or throwing the object. In both cases I am considering the acceleration as gravity. Okay, so don't get confused between the acceleration is maximum and acceleration due to gravity. Okay, so answer is 4. Option 4 is the answer. Yes, Abhishek, option 4 is the answer, correct. Right now? So next question. A body falling from height h takes time t1 to reach the ground. Okay, so falling from height h. So what I should take, object is, sorry, there is a tower, okay, which is of height h. Falling means it's going towards down, gravity towards down. How much time it has been taken? t1. The time taken to cover the first half of the height is, so time taken to cover first half of the height, so total time it is t1. I need to find the first half, right? No, so what is the time equation we have got there? V is equals to under root of 2g h. No, this is for velocity, but for time what is? T is equals to u by g. One more equation is there, no, T is equals to under root of 2h by g. Yes, no, 2h by g. Got it? How 2h by g will get there?
By
shifting the terms by using the equation we got. Yes, no? So we'll see. We got na? Yes, no? 2h by g. Now where is the question? Yes, in this question this is the formula, no? Let me take the formula t1. T1 means total height h, no? Total height h. So equals to root over 2h by g. What is T2? T2 is nothing but half of the height, no? Half of the height in the sense h by 2. Yes, na? So root over 2 into h by 2 in 2 by g. Done, no? So what I should do now? Let me take this. They are asking T2 in terms of T1, no? So what I will do here is I will rearrange something here. 2h by 2 into g, where 2h by g is T1, right? No, T1. I will take this root 2 separately outside, right? No, I will take root 2 separately outside, which becomes T1 by root 2. T2 equals to T1 by root 2. So option?
second.
That's it. Done? Any doubts in this now? We'll see one more question and we'll end this session, okay? We'll see the question? Yeah. A body is dropped, wait a minute, let me zoom it. Yes. A body is dropped from a tower, reaches the ground in 4 seconds. Okay, the height of the tower is about. So now only we solved that, right now. So it is, there is a ball, I mean a body is there, okay, it has been dropped. So what is the time equation in terms of h? Root over 2h by g. Sorry, g, no, it is g. So they are asking the height of the tower, right? No, 4 seconds. So let me take this is t square is equals to 2h by g, where h is equals to how much? T square g by 2. Yes, no? Done? Now I can solve this question, no? T square how much? 4 square into g 10 and by 2. how much will be the answer? H is equals to t square is 4 square, no, 16 into 10 divided by 2, which is nothing but 1 times and this 8 times. Answer is 80 meter. Option
16 times
4.
divided by 2 is 80.
Right now?
So you told you have to take 9.8 and not.
Like we are taking if they mention 9.8.
Ah, okay.
Okay. If they have not mentioned, we can use 10 only approximately. Okay. Done. So is it clear about today's class? Any doubt in the class now? So we have seen two things. One is vertical motion. In that vertical motion, free falling body and object thrown upward. Okay. So by using the equation, we solve the questions. That is one thing. When I am taking the object, that is free falling body, A should be G, positive G. I am throwing the object, A should be minus G. Okay. Remember the two things. Okay. The direction of the acceleration and the gravity. So according to, you can solve the problem. Okay guys, bye bye. We'll meet in the next class. Fine.